In this video, we introduce our work, TransGrasp. Grasp pose estimation of a category of objects by transferring grasps from only one labeled instance. 6 degree of freedom grasp pose estimation refers to the problem of finding a grasp configuration for the grasping task given an object. It's one of the most important issues for robots to interact with the real world. Currently, most existing works rely on grasp pose annotations on each object or exact 3D object models available beforehand. However, annotating 6D grasp pose is not easy. Thus, in this paper, we aim to estimate the grasp poses of all instances by labeling on only one instance of the category. As we know, objects classified by shape usually have consistent topologies and grasping affordances, and they are likely to be successfully grasped in a similar way. Based on this prior, we can firstly build the categorical dense correspondence across object instances. And then, grasp poses could be transferred from one object to others. The details of our method are as follows. We build an encoder-decoder framework to reconstruct object model given partial point cloud, and provide dense shape correspondence between the reconstructed model and the template. After training, each 3D shape is mapped to a latent code Z. TemplateNet captures the common properties of a category, and DeformNet learns a deformation for each object to the template. To complete the shape information, a shape encoder learns to map each input to the latent shape code Z. Note that during the training process, no grasp annotations are needed. To easily implement grasp transfer using dense correspondence between objects, we introduce a novel suitable grasp representation. We denote the two grasp points on the object surface projected from gripper as P1, P2, the vertical distance from gripper's origin O to the line linking P1 and P2 as approaching depth D, and the approaching vector as V. With our grasp pose representation and one labeled source object, the grasp poses could then be transferred to other object instances of the same category during the inference procedure. Given grasp points on the source object, their deformation offsets to the template are predicted by DeformNet, then its grasp poses on the template will be obtained by this deformation accordingly. For target object, it obtains the complete reconstructed shape by the encoder-decoder framework. And its surface query points are deformed to the template by DeformNet. Lastly, we apply the nearest point matching to transfer the grasp points on the source to the target. However, when handling some outlier objects with strange shapes, poor deformation could be estimated by DeformNet, which in turn leads to the failure of grasp transfer. Therefore, we propose a grasp pose refinement module to improve performance after grasp transfer. We first encourage the two grasp points to satisfy the antipodal principle on the object surface. For the two-finger grasping problem, the grasp points are antipodal when their normals are in opposite directions and stay in one line with the grasp points. The antipodal loss is defined according to the antipodal principle functions. In addition, we also design other loss functions. We use the touch loss to ensure that the grasp points are on the object surface. We build collision avoidance loss to penalize the interpenetration between the gripper and object. Besides, we apply regularization loss to prevent excessive deviation from stable grasp poses. We use ECCV to evaluate grasp success rate of our method. Compared with other methods, TransGrasp obtains the highest success rate for mug and bottle, and achieves comparable performance with 6DOF GraspNet for bowl. To verify the practical application of our method, we further conduct grasping experiments on a real robot. This video shows some of our grasping results in the real-world setting. To sum up, the contributions of our method are listed as follows. Our code is available on GitHub, and more information about TransGrasp can be seen on our project page. Thanks for your watching.